Okay, bachcho, we are solving question number 23. Question number 23 is figure 1.1 shows a motorcycle during a race. This is a motorcycle and it is during a race. The motorcycle accelerates along a straight section of the track from a speed of 40 meter per second to maximum speed to maximum speed. Figure 1.1 is the speed time graph for the motorcycle along the straight section of the track. So this figure is the speed time graph of the motorcycle for the straight section only. Okay. And now what they are saying. The mass of the motorcycle is 180 kg. For the time 0 to 2 second determine the acceleration of the motorcycle. Now first we have to observe whether it's a straight line or a curve. I think from 0 to 2 second it's a straight line, which means that it is uniform acceleration and tangent is not needed. Because if the acceleration is non-uniform, then at the given point you have to draw the tangent. But here they're asking the acceleration over an interval where it's constant. So from 0 to 2 second, here we have 2 second. The acceleration is constant. So to calculate this acceleration, we can calculate the slope between 0 to 2 second. Now, if we take any 2 points between 0 to 2 second, one point could be the starting point. The other point could be, we can take 2 second. So at 2 second, speed is, the speed is basically from 50 to 60. How many divisions are there? They are, as you see, 1, 2, 3, 4. You have 5 divisions. So every division represents 2. 5 divisions are representing 10 because 50 to 60 it's 10. And one division will represent 10 over 5. So it's 2 meter per second. So it's 52, 54, and I think it is 55. So this point is 55 meter per second. So this is 2 and 55 meter per second and 0 and 40 meter per second. So if we calculate the slope of speed time graph, it will be the acceleration. If it's a straight line motion, then slope is y2 minus y1 over x2 minus x1. Here y is speed and x is time. So 55, this is 55 here. 55 minus 40 because the starting point is 40. And that will be divided by 2 is the final point, 2 is the time at final point, and 0 is the time at the starting point. So it will be 15 over 2. That should be 7.5 meter per second square. So 7.5 meter per second square. If the unit is not given, then you have to write it by yourself. If you miss a unit, you're going to lose 1 mark. So while writing your answers, units are compulsory. If a unit is missing, you're supposed to write that. Now, the second part of the question, the resultant force acting on the motorcycle. You have acceleration, you have mass. You can just go with F is equal to M into A. So it's 180 kilogram and then multiplied with 7.5 meter per second square. So it will become 180 into 7.5. That is basically 1350. And unit for force is, as you see, it's Newton. Now the next part. The driving force acting on the motorcycle remains constant throughout 12 seconds spent on the straight section of the track. This is a graph of those 12 seconds. Now, use figure 1.2 to describe how the acceleration of the motorcycle changes during the time. One thing is obvious. In the beginning, it's a uniform acceleration. Then it is decreasing acceleration. Then at this time, what is this value of time? Every division of time represents, as you see, in 10 divisions we have 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every division is 0.2. So here it's 6.2, 6.4, 6.6. So logically it's a point that is 6.6 second. After 6.6 seconds, no, it's not a straight line after 6.6. It's a straight line. We have to see with ruler basically. So observing with the ruler will be a good idea. So I think the line is straight up to this point, I think. So this is the point of time after which we are having a straight line. So for 2 seconds, it's a straight line, then it's a curve, then after 8 seconds, it's a horizontal line. So we should say from 0 second, from 0 second to 2 seconds, the acceleration was, because it's a straight line, when speed time graph is a straight line, the acceleration is uniform. The acceleration is uniform from 2 seconds to 8 seconds. It's a decreasing curve, so the acceleration, when they say describe, reasons are not needed. You have to describe the process, the changes. You only have to describe, no need to explain. The acceleration decreasing since it's a decreasing curve. So acceleration is decreasing. After 8 seconds, no acceleration. After 8 seconds, there is no acceleration at all because the speed is constant. Explain in terms of forces acting why the acceleration changes in this way. Basically, after some time, the air resistance goes on to increase because an increase of speed will increase the air resistance. So it's the increase of air resistance which results in a decrease of acceleration. So we can say that, explain in terms of forces acting. So we can say that driving force is constant as it is given by the examiner, I think. They have given this, I think, somewhere. Accelerates along a straight line, maximum speed, track, motorcycle during a race. Acha. Then motorcycle has 180 determined acceleration resultant force. The driving force remains constant. It is given here. I was searching for this. The driving force is constant, then obviously resistive forces are changing. Driving force is constant with increase of speed, air resistance will go on to increase. Air resistance will go on to increase, resulting in a decrease of resultant force, and hence acceleration. Acceleration is also decreasing. After 8 seconds, the resistive forces become equal to, combined resistive forces refer to the air resistance and the road friction. The resistive forces become equal to driving force and no resultant force on the motorcycle. That's why the speed becomes constant. So when the resultant force becomes zero. The motorcycle will have no acceleration and the speed will become constant. So this is the answer.